NASA once believed Titan was hiding something extraordinary beneath its frozen surface. A vast underground ocean. Liquid water. Possibly even the conditions for life. But what scientists have uncovered now is far more unsettling than anyone expected. Titan is not just another moon. It is cold, distant, and wrapped in a thick orange haze that hides its true nature. For years, data from NASA's Cassini spacecraft seemed to confirm that beneath Titan's icy shell, a global ocean of water was slowly shifting and responding to Saturn's gravity. That idea shaped everything we thought we knew about Titan. But when researchers re-examined the data using modern physics models, the story began to fall apart. Because Titan did respond to gravity, just not in the way an ocean world should. What NASA found wasn't an ocean at all. It was something far stranger. Something no one had seriously considered before. Titan is Saturn's largest moon, and in many ways, it is one of the most Earth-like worlds we've ever discovered. It is the only moon in the solar system with a thick atmosphere, dense enough to scatter sunlight and create weather. On Titan, clouds form. Rain falls. Rivers carve channels across the surface. But instead of water, those rivers flow with liquid methane and ethane, creating lakes and seas that stretch for hundreds of kilometers. Temperatures on Titan are brutally cold, nearly minus 180 degrees Celsius. Water there is frozen solid, harder than rock. Yet beneath that frozen, scientists long believed heat from the interior kept a vast ocean of liquid water from freezing. Titan also contains complex organic molecules, the same chemical building blocks thought to exist on early Earth before life emerged. This combination, chemistry, energy, and liquid, made Titan one of the most promising places to search for life beyond Earth. For decades, Titan was seen as a time capsule, a preserved version of what Earth may have looked like billions of years ago. A world where life might still be quietly waiting to be discovered. That belief made Titan one of NASA's most important scientific targets. But it also made the new discovery deeply unsettling. The theory of an underground ocean on Titan was built on years of precise observations from NASA's Cassini spacecraft as it repeatedly flew past the moon. Each close encounter allowed scientists to measure tiny changes in Titan's gravity field, rotation, and shape with extreme accuracy. As Titan orbited Saturn, the giant planet's gravity stretched and squeezed the moon, creating tidal forces similar to those that flex Earth's oceans. Cassini detected that Titan's outer ice shell appeared to move independently from its deeper interior. This behavior matched predictions for a global ocean of liquid water hidden beneath the ice. Computer models showed that a liquid layer would allow the surface to deform smoothly as Saturn's pull changed over time. Many scientists concluded the ocean was mixed with ammonia, lowering its freezing point and keeping it liquid for billions of years. Such stability made Titan a prime candidate for habitability. A protected ocean, shielded from radiation and rich in organic chemistry, seemed ideal for life.
This anomaly here, it matches
Titan
the signature
was placed
from the
alongside
earlier
Europa and
Let me
Enceladus
cross-reference the
as one of the most
stabilization
promising
matrix.
ocean worlds
stable.
in the solar system. But buried within the data was a subtle inconsistency. When researchers examined how quickly Titan reacted to Saturn's gravitational tug, the response appeared delayed. The moon did not flex immediately. Instead, the deformation lagged behind the changing forces by many hours. At first, this delay was dismissed as noise or uncertainty. Yet, as measurements improved, the delay became impossible to ignore. A simple, freely moving ocean could not explain such sluggish behavior. That single mismatch would eventually force
Look at the
scientists
derivation
to question
here.
the
If we
entire
isolate
ocean
for the variable,
hypothesis.
it stabilizes the entire
That realization
dataset.
marked the
We've done
moment
it.
when confidence began to fade, opening the door to alternative explanations that would soon challenge long-held assumptions about Titan's interior structure and its place among supposed ocean worlds everywhere across the outer solar system research community globally. When scientists returned to Cassini's measurements using improved interior models, Titan's behavior no longer matched that of a classic ocean world. A true subsurface ocean should respond rapidly to changing gravitational forces, flexing almost in real time. Titan did not. Its surface deformation occurred slowly, resisting Saturn's pull as if the interior were thick and stiff. This unexpected resistance pointed to a very different structure beneath the ice. Instead of a vast, continuous ocean, researchers proposed layers of ice mixed with water and salts, forming a massive, slushy interior. This material behaves neither like solid ice nor like free-flowing liquid.
The viral load is doubling every hour.
Absorbs stress
This can't be right.
and releases
Run the
energy
sequence again.
over long periods.
We need confirmation.
Such a structure perfectly explains the 15-hour delay observed in Titan's tidal response. The moon was not bending because water was sloshing beneath the surface. It was yielding because its interior was slowly creeping under immense stress. This revelation overturned decades of planetary models. Titan was no longer a straightforward ocean moon. It became a transitional world, existing between solid and liquid states. Water was still present, but locked into a complex, partially frozen system. This forced scientists to reconsider how habitability should be defined. A slushy interior challenges assumptions about heat transfer, chemistry, and long-term stability. It also raised an unsettling possibility. If Titan was misunderstood for so long, other icy moons may also hide interiors far more complex than previously believed. What appeared simple from afar may, in reality, be profoundly alien beneath the surface. This shift transformed Titan from a single target into a warning sign, reminding planetary scientists that indirect data can mislead, and that unseen interiors may defy intuition, demanding humility, caution, and new exploration strategies as humanity pushes deeper into the solar system. With future missions relying on stronger models, patience, and deeper analytical rigor across multiple planetary environments simultaneously. The most unexpected consequence of this discovery lies in what the slushy interior can actually do. Unlike a freely moving ocean, slush traps heat and releases it slowly over time. This means Titan may remain internally warm far longer than scientists predicted. Within that thick mixture of ice and water, small pockets of liquid could persist for millions of years. These isolated environments would be hidden, stable, and incredibly difficult to detect from orbit. If life exists on Titan, it may not fill a vast ocean.
Cracking like
It
ice.
may survive in scattered refuges, evolving slowly in darkness. This possibility forces a radical rethink of habitability. Life may not require open water, sunlight, or global stability. It may only need chemistry, energy, and patience. Titan suggests that life could exist quietly, sparsely, and invisibly. This idea expands the number of potentially habitable worlds dramatically. Frozen moons, dwarf planets, and even rogue worlds may host similar interiors. Titan may represent a class of worlds more common than Earth-like planets. In that sense, Titan becomes a mirror. It reflects our assumptions back at us. NASA did not simply lose an ocean hypothesis. It gained a deeper, stranger understanding of how nature builds worlds. Titan reminds us that the universe does not optimize for familiarity. It experiments endlessly, producing environments that challenge every rule we think we know about where life can exist. This realization reshapes astrobiology itself. Scientists must now search for subtle signals, not obvious oceans. Heat flow, chemistry, and time become more important than appearance. Titan teaches humility. It warns that comfortingly simple models may hide extraordinary complexity beneath. The universe may favor strange compromises over clean solutions,
This is a significant
creating
step
niches
forward.
where life persists quietly,
Congratulations,
unnoticed,
truly. The
and
validation is
misunderstood for
clear.
centuries, until technology, patience, and imagination finally catch up. forcing future explorers to question conclusions
Look at the
drawn from
derivation
distant
here.
measurements
If we
alone,
isolate for the
without
variable,
direct
it
confirmation.
stabilizes the entire
ever.
data set.
Despite the
We've done
surprise, Titan remains one of NASA's most important exploration targets. The discovery did not end interest in the moon. It reshaped the questions being asked. Instead of searching for a single hidden ocean, scientists are now focused on chemistry, energy, and movement across Titan's surface. This shift is exactly why NASA approved the Dragonfly mission. Dragonfly is a nuclear-powered rotorcraft designed to fly through Titan's dense atmosphere and land at dozens of locations. Titan's low gravity and thick air make controlled flight easier than anywhere else beyond Earth. Dragonfly will analyze organic molecules, surface materials, and possible chemical reactions linked to life. It will move from dunes to impact craters, sampling environments shaped by very different processes. Rather than drilling deep underground, Dragonfly will study how complex chemistry evolves at the surface and near subsurface. These measurements may reveal how life's building blocks form even without a global ocean. Dragonfly represents a new strategy for exploration. Instead of assuming familiar conditions, NASA is preparing to study worlds exactly as they are. Titan is no longer just a destination. It is a test case for how humanity explores truly alien environments across the solar system. Lessons learned here will guide future missions to icy moons, rogue planets, and distant exoplanets, shaping exploration strategies for decades while reducing assumptions that once limited our understanding of unfamiliar worlds everywhere beyond. Titan revealed a truth that scientists rarely like to admit. Our expectations often shape what we believe we see. For decades, Titan was labeled an ocean world, a familiar category that fit comfortably within existing theories. But reality turned out to be stranger and less convenient. Titan did not confirm our assumptions. It challenged them. It reminded us that nature does not follow human classifications. Somewhere beneath that orange haze lies a world that operates on rules we are only beginning to understand. And if Titan managed to hide its true nature in plain sight, then countless other worlds may be doing the same. Worlds we have already observed. Worlds we think we understand. Worlds quietly waiting for us to look again, ask harder questions, and accept that the universe is more inventive than our imagination has ever allowed.